Hi, my name is Natalia, and I'm going to present my doctoral qualified examination proposal, which title is Assessing Product Creativity in K-12 Computing Education. So, creativity is one of the 21st century competencies essential for professional and personal success. And although creativity is traditionally associated with arts, music, literature, it can also be developed as part of computing. There are many definitions of creativity and also many disagreements on the definition. So, creativity generally is defined as the capacity to generate new, original, or surprising ideas and solutions. A creative idea or solution is considered original if it represents something novel that did not exist before. And creativity is a multidimensional construct. It can be represented from different perspectives. For example, one of them is the four P's of creativity proposed by Rhodes, which divides creativity into press, process, person, and product. Here we focus on the product, which refers to the tangible outcomes of the creative process. And although all four P's plays a crucial role in understanding creativity, the analysis of the product can allow insights on the concepts of creativity as a whole. Similarly, creativity can be assessed taking into consideration not only one of the four P's, but also the level from individual to culture, and also the type of the measurement approach, objective, self-rating, or other ratings. Here, we focus on the assessment of creativity on the strength of the product, on the individual and team level, classroom level, using an objective approach. Focusing specifically on product creativity, it is commonly divided into three dimensions: originality, utility, and quality. Those are considered by most authors as the most important dimensions of creative product. Originality refers to a product level of surprisingness, newness, uniqueness, etc. Utility measures the extent to which a product meets the practical needs of a problem situation, and quality considers the aspects of style, attractiveness, complexity, completeness, etc. Well, computing is recognized as a creative human activity because it enables innovation and allows people to create novel artifacts. So, computing can foster creativity and innovation because it provides learners with the opportunity to create innovative programs to new and unexpected problems. In computing education, creativity can be developed by teaching the development of mobile applications. For example, adopting the computational action strategy. Students learn basic computing concepts and develop mobile applications using App Inventor. In computational action, students create apps on a theme they care about. For example, Julia, a middle school student. Well, Julia cares a lot for vegan restaurants. She wants to be able to know where she can go. So she created an app that allows you to view restaurants with vegan and vegetarian options on a map. Similarly, Maria and Manuela like plants very much. So they create an app that provides information to help care for plants at home. However, in computing education, creative problems are initially very complex, and the students often have difficulties with the first steps when learning to program. Commonly, we use modify create cycle or something similar as a basis for the progression of learning computing concepts as well as increasing the creativity level. Following this cycle, students first use a given predefined code, artifact, or app. Then they remix or modify an existing one, modifying scope, strategy, code, etc. And on the last step, they eventually create new ones. The create phase is essential, giving the learners the opportunity to improve their competencies related to algorithms and programming, and also to express themselves and create something in areas they care about. But, well, assessing creativity is challenging, especially in this open context of the create stage. In this case, one alternative is performance assessments on the creative product, representing the outcome of the learning process created by the students. Such assessments typically measure whether the properties um, that are present in the outcomes and to what degree. However, despite the recognition of the importance of assessing creativity with respect to the creative product, there is a lack of valid and reliable approaches. Thus, the research question guiding this research is how to systematically and automatically assess product creativity in K-12 computing education. The main objective of this research is to develop and evaluate an automated approach for assessing product creativity based on mobile applications created by students as a result of ill-defined activities in the K-12 computing education context. To achieve this objective, we aim at developing a conceptual model that specifies criteria and performance levels for assessing creativity and integrate it in the Codemaster tool. The defined approach to achieve the objective of this work is divided into 7 steps. In step 1, for identifying the state of the art in practice, we perform a systematic mapping study. In step 2, the domain is analyzed based on the results of the literature reviews, curriculum guidelines, and the analysis of the educational context. In this step, we gather information about how creativity in mobile applications is perceived and communicated, as well as concepts, terminology, tools, representational forms, etc. In step 3, there is domain modeling. Here we define creativity product dimensions to be assessed. We define the student's model, considering focal and additional knowledge, skills, abilities. The evidence model, describing potential product observations. In step 4, the conceptual model is developed using a series of different methods, including PED task templates, goal question metric, etc. Once determined, we review the criteria and features. In step 5, we implement the assessment and calibrate the measurement models for the 3 dimensions. In step 6, we deliver the assessments in a real-world scenario by performing a case study. Finally, in step 7, we evaluate the model regarding its reliability and validity using a series of statistical methods. So, on the state of the art, in order to identify which studies exist for the assessment of product creativity or some of its dimensions of computer program in educational contexts. We performed a systematic mapping on January 2020. We defined the research question into 5 analysis questions. Let's see the first one. Which studies exist and for what kind of product and educational stage? Well, the approach targets different educational stages. The majority of studies were designed for some stage in K-12 education, while others target higher education. They use a set of different programming environments from Scratch, Inventor, Agent Sheets, and even JavaScript, etc. Question 2. What is the definition of the product creativity dimensions being assessed? We observed that the most analyzed dimension is originality. Although authors use different terms such as novelty, etc., they refer to the same concept of originality. Quality is the second one assessed by almost half the approach, and utility is assessed by only 2 approaches. Key 3. How are these creativity dimensions analyzed? The approach vary largely on the type of assessment methods and techniques used. For example, we found the rubrics, expert assessment based on personal knowledge as input to automated assessment, automated techniques from computer science, mathematics. Some studies also use psychological tests such as the TTCT, Torrance test of creative thinking, but those tests are not created for computing education. Regarding automation, half the approach are automated. Question 4. What is the context and sample size of the application of the approach? The majority of the approach were applied in face-to-face K-12 school classes. Blended applications with face-to-face and online K-12 school classes were applied in middle school contexts. The sample size varies from small samples, for example, 16 students in face-to-face university classes, to large samples obtained from, for example, project galleries with more than 200,000 projects. Question 5. If and how the approach has been evaluated? Well, most articles do not present an evaluation of the approach. Some assume the reliability and validity of the existing tests, such as the TTCT, or psychology test. And some approaches performed an evaluation on reliability, agreement, inter-rater agreement with coherence kappa, etc. So, in a nutshell, most approaches assess originality as a dimension of the creative product. They also assess ill-defined activities. Some approaches perform automated assessment and utility and quality as dimensions of the creative product. And most approaches do not define creativity systematically, evaluate the approach proposed, and most approaches do not assess mobile apps as the product creates as a learning outcome. So there is a lack of research on assessment of learning creativity on this range of the product as part of computing education, as well as evaluation of the approaches. So the proposal, we first performed a domain analysis. In this context, we are working with elementary and high school students. They typically have between 12 and 18 years. For computing education concepts, it includes not only programming but other areas such as human-computer interaction, software engineering, etc. In Brazil, although there is a substantial inequality between public and private schools. Most of the schools have a usable computer lab and connection to the internet. Considering K-12 teachers, unfortunately, most schools do not have teachers with a teaching degree in computing. So, interdisciplinary applications are very common. Considering the active learning approach and the strategy to progressively develop creativity with the use, modify, create cycle, here the assessment objective is defined as to analyze the mobile application created as a learning outcome for evaluation purposes with respect to creativity from the student instructor's point of view in the context of the creation stage of computing education in K-12 through the development of mobile applications. So, for a pedagogic approach for product creativity of mobile applications, in the create stage, students can follow different process to develop new apps with new scope, new strategy, new features, new design, etc. And this app is considered creative uh, in relation to a reference universe, which is composed by apps made by people with similar experience in training. For example, apps created by other students from the same classroom. Considering the use, modify, create cycle, at the create level, the general learning objective is that the student should be able to create a mobile application that is original in terms of strategy, scope, skeleton, surface, and source code, useful in terms of strategy and scope, um, and with quality in terms of skeleton, surface, and source code. Here, utility and quality are important in order to eliminate unfeasible, absurd, unpleasant, and unprofessional mobile apps. However, those may not be easily automated, especially utility. There's also additional knowledge, skills, and abilities students need to be able to develop apps with App Inventor covering computing concepts in practice. Considering the focus on the product creativity of mobile applications, potential observations rely on the analysis of the student's mobile application. So, for originality, it means determining the degree to which the mobile applications is different from the universe of reference of mobile applications created by students in a similar context, for example, in a classroom. For utility, determining the degree to which the mobile applications is useful considering user needs. And for quality, determining the degree to which the mobile application has quality considering design and code aspects. Each dimension of product creativity is analyzed considering its nature in accordance to the layers of Garrett's framework. Considering originality, all layers are included except structure. Utility is more related to strategy in part of scope, and quality is assessed based on the most concrete layers from visual design and source code. So for assessing product objectives and content, we first extract the mobile application content. Then, based on the content, we identify the topics from the required distribution. We can then compare the rarity of these topics by seeing how frequent they are in the reference universe. If something appears quite often, well, maybe it is not. And Original, okay. For determining how many topics, we may want to use hyperparameter tuning, for example, a coherence indicator or something similar. Focusing now on the functional specifications, we first extract the feature from the app using a rule-based script. Then again, we compare it with a reference universe and assign a degree of rarity of features. Based on this evidence, we can assign the originality degree of functional specifications. Well, the most part we are in contact with a mobile application is the interface and sensory design. Most of our human-based assessments of mobile applications are based on this look and feel. Thus, we gather the frequency of visual components, its colors, types, etc., and compare it with a reference universe for computing the rarity degree, which is used as an input for analyzing the originality and assigning degree. Considering that we are working with computational artifacts, we may also want to know the originality of the code. In source code originality analysis, we use frequency vectors. These frequency vectors can be represented as raw, binary, or relative representation, such as TF-IDF. Based on these vectors, we can use the Cherry Mobile as an input and the reference universe for performing a similarity analysis using cosine or Euclidean distance or something similar. Based on the results of similarity, we can analyze originality and assign its degree. Thus, the assessment of originality includes these four models, which are combined to provide a general degree of originality. Of course, originality can have many nuances, so we can have a result of a computational artifact to be considered very original, or on the other hand, it's too similar to what exists. And here we must be very careful what we mean, what exists. We must consider the classroom context because we must not expect our students to revolutionize the world when creating a single app. We also should not disregard a computational artifact as unoriginal if there is a high degree of originality for the context of elementary school students. There's also each submodel for utility and quality. So the next steps include specify the assessment of the construct of creativity product dimensions, originality, utility, quality, develop assessment activities and calibrate the measure models for originality, utility, and quality, and integrate the assessment in the Codemaster tool. Define and apply the assessment in practice, collect data and report results, analyze the model's quality. This research has and will produce scientific, technological, and social contributions. The main scientific contribution is a model to systematically assess product creativity based on software artifacts. The main technical contribution is the conceptual assessment model integrated in the Codemaster tool. And the social contribution is the support for the development of creativity as part of computing education and thus contributing to the development of 21st century skills as part of computing education in K-12. According to PPGCC rules, the candidate for doctoral degree must present proof of publication of at least 2 full-page articles, and one of them must be in a journal of the restricted index of Cyclopical Qualis. The good news here is that those scientific production requirements have already been achieved. Considering also that I'm working constantly in touch with other colleagues of the GKS lab and computing article initiative, so far we have worked in many additional articles as well. Thus, the current status is language proficiency test okay, PPGCC seminars okay, teaching internships okay, scientific production okay, discipline credits okay, and also some extracurricular activities. Um, since the progress seminar from last year, pandemics work, etc., the schedule has changed a little, but we intend to defend in March 2023. That being said, I wrap it up here. Thank you very much for your attention.